Hey guys, Tim with Little Crow Gunworks. Welcome back to the channel. Today we are going to take you out to the farm and stretch the old 308 out at long range and test a few different loads at long range with larger sample sizes and see how we shake out there. Before we do that, I want to say thank you to you guys for your continued support. Series is still going really well, and it turns out this is helping out a whole lot of people. A lot of you guys are applying this to your testing and seeing immediate, sometimes very drastic results. So that's good. I'm glad to hear that. This video is primarily going to be showing you guys the shooting footage at long range, and then when we come back, we're going to analyze all the data. But before I dive into the screen recording here, one thing I want to talk about that we haven't talked about yet in this series that is can be viewed as kind of a fringe deal. You know, this series is called What Really Matters, and because I'm a long range guy, it's all through that lens. And there's a lot of things that competitive shooters and even non-competitive shooters do that I don't do. But one thing that I do, if I really want the gun to shoot as small as possible at long range, that some of the competitive shooters do as well, and even non-competitive shooters, is bullet sorting. So I mentioned early on in the with the Pareto graph that I don't do any type of brass sorting, but I do sort bullets for my competitive target rifles if they're shooting a hollow point. So we'll talk about bullet sorting here briefly. Because of what you're going to see on the screen recording, it's not going to make sense unless we talk about this. So bullet sorting, how do we keep this brief? There's a lot of different ways to do it. I will say that based on what I'm seeing from the top level shooters, there's only really one way of sorting that there's a lot of meat on the bone and payoff for the time you're spending on it, and that is sorting the bullets by overall length, not base to ogive, not by bearing surface, not by whatever, base to start a bearing surface, not by whatever. The guys that are winning at the very top level are sorting by overall length of the projectile, and they're not sorting it any other way. They're not weighing bullets. You know, Brian Litz has been quoted saying that the only value in weighing bullets is in case there's a bullet in your box that's the wrong weight. Meaning, like, if you have a box of 175 grain bullets and a 168 made it in there somehow, that's the only value in weighing bullets. If you don't find a bullet that doesn't belong because it's the wrong SKU, there's no value in it. And as far as the sorting by dimensions, the reason sorting by overall length is so important is because that helps you sort out the bullets by their ballistic coefficient. So if you sort by base to ogive or by bearing surface or whatever, you're going to find that if it's a reputable bullet manufacturer, Sierra, Berger, Barnes, Hornady, whatever, you're going to find that the bearing surface length, they're all going to be within a thousandth or two. Base to ogive, same thing. They're all going to be extremely similar, within a few thousandths. If you take a box of hollow point, lead core hollow point bullets and sort by overall length, you're going to have anywhere from 10 to 60 thousandths in variation, not 1 or 2 or 3. You're going to have huge variances, which means that all the variance is out here on the nose, where all the drag is. Remember we talked about in the bullet video where the center of pressure is out here on the nose. So if all the nose variation is in the length, that's going to have the highest impact on, or the greatest impact on, the ballistic coefficient of the bullet. So when Applied Ballistics did all their bullet testing for their books, they not only tested and figured out what the average ballistic coefficient is, but they also figured out the variance. So like if a G7 ballistic coefficient on a box of bullets is 0.300, that doesn't mean every bullet in the box is 0.300. That's the average. There's a variance. And depending on how sloppy your overall length is, that variance could be anywhere from 0.290 up to 0.310. It could be 0.295 to 0.305. It could be, the variance can change quite a bit, and the variance depends on how long the nose is and therefore how long the projectile is. So if you're going to sort, basically in summary, if you're going to sort bullets, the only valuable way to do it is by overall length. And I think if you cluster the batches into, say, 3,000ths or something like that, that's adequate. You don't need to sort every bullet to the 1,000th. I think in clusters of 3,000ths is good enough. And what you'll see is that will usually distribute like a bell curve too, where let's say the average length is 1.5 inches for a given bullet. Well, you're going to see that most of the bullets are around that 1.5 inches, and then as you go out toward the fringes, there's less and less, where instead of 1.5 inches, if you have 1.530, where that bullet's 30,000ths longer than the average, there might be 1 or 2 of those in a box of 100. So what you'll notice is that you're going to have a big concentration in the middle, and then as you get out towards the extremes, there'll be very few. And what I recommend if you are going to sort lead core hollow point bullets is shoot up those fringe ones on the ends, the longest ones and the shortest ones. Shoot those up during ladder testing or doing your initial 10-shot or 15-shot ladders to sort out powder. Like, sort all your bullets before you start shooting them and shoot up those outliers at the beginning, so by the time you get to where you're actually testing at long range, all you have left is that big cluster in the middle that are all very similar in length, and therefore will all have very similar BCs. So when we go into the screen recording here, you're going to see where I put, for what we tested, I put identical bullets. Well, that's what that means, is that all the bullets were the exact same length. Because I had enough, I didn't cluster them into groups of 3,000ths variants. I got them all to the 1,000th, and then I had little bags of, each individual length, and then I shot those for the same test, so we were taking that variable out of the equation. All right, so now that we got through that, looks like that was a few minutes. Let's get into our screen recording here, and we'll talk about what we tested and the testing conditions, and then we'll take you out to the farm and show you all the shooting footage, and then we'll come back and review all the results at the desk here. 3, 2, 1, and we're live. Okay, so because I was going to be doing larger sample size testing, I wanted to not only test our 2 Contender loads, but I wanted to have a couple other things here to test. So we'll just start at the top. The first thing we tested was our faster load, the 43.0 grains. That was all identical bullets. Again, all the bullets were the exact same length that I sorted. They all had identical, all the loads. So when I say all the loads, for each of these things that I tested, I did 10-shot groups. So we'll include the sample size police here. When I'm doing the load development at 100 yards, that's why I say I'm looking for trends. I'm just looking for feedback that tells me, okay, this general area looks like it wants to behave, even though we're not using large samples, statistically relevant samples. And that allows me to pick contenders. Then once I have the contenders, then when I go out to long range, I'll do larger sample sizes to make sure I don't just get 3 really good shots, when in reality, if I put more shots on it, it starts falling apart. I actually want to put enough data down range to go, okay, what is this thing really doing? And get a much better idea. So basically, it's, even though we did extensive testing at 100 yards, I'm trying to kind of abbreviate that and just be able to pick winners and losers based on the trends I'm seeing, and then spend more components at long range so I can really get an idea of what the thing's trying to tell me. So the first thing we tested, again, was our higher charge weight, 43.0 grains, all identical bullets, identical charge to the kernel, and identical cartridge base to ogive, so identical seating depth to the 1,000th. Based on the 100-yard metrics, I assumed that this would be the best load, and we'll see where we shake out. And then remember our slower load was 41.9 grains. Again, identical bullets, charge, and cartridge-based ogive. Based on the 100-yard metrics, I assumed this would be second best. And then we brought a control, 40.8 grains. Again, identical bullets, charge, and cartridge-based ogive. Random load with no development. And that's my control. And that was basically the, when I did that initial big ladder test with whatever it was, 15 different charge weights, and I did 3-shot groups. That was the very first charge weight where it pounded 2 together and then it spit one way out the top. And I think it was the one with the lower extreme spread, or maybe it was the higher. Anyway, it was one of those first 2 charge weights that both basically grouped the same, where they had 2 together and then spit one out the top. So I thought, that got no development whatsoever. I'll load up 10 of those and just fling them down range and see what happens. And then the fourth thing here, same charge weight, 40.8 grains, but I wanted to test bullet variability. So those all had identical charge weight to the kernel and identical cartridge-based ogive. But what I did was, okay, I have 10 shots. Each bullet was a different length. So I think I said at some point in the series, because these are a short, fat design, there's not a lot of variance in length. So I basically loaded up 10 different bullets that were a different length by 1,000th. So there was only 10,000ths variance between the first one and the last one. And I wanted to see, okay, as we get longer in bullet length, is that increasing the ballistic coefficient enough that the shots are going to start rising on target? Because if the BC is higher, that means it slows down less. So as the bullets get longer and the BC gets higher, do the shots start drifting up? To see how much 10,000ths variance really matters. So for those of you that aren't going to sort bullets, well, if you're going to shoot a really high BC sexy design and you're not going to sort bullets, there won't be 10,000ths variance in a box of bullets. There'll be like 30, 40, 50, 60,000ths variance. So I wanted to see, just because of the short fat design, I couldn't test 60,000ths variance because that didn't exist within that box, or within the 3 to 4 boxes that I used, because they were all the same lot. All there was like 10,000ths variance. There might have been 12. I think there was 12, but I thought, okay, I'll pick the 10,000ths, eliminate the 2 on the end, and pick the 10 in the middle and just test those. And then the fifth thing I tested was charge variability. For those of you that are using powder measures or have a sloppy charge weight for whatever reason. And I tested in 0.04 grain increments. So the total variability, so each shot was a different charge weight, from 40.64 grains to 41.0 grains. So it's almost a 0.4 grain charge variance. Had I shot 11 shots, it would have been 0.4. But at any rate, I wanted to see, okay, with 40.8 grains as the average, and if I start having a sloppy charge going lower and higher, how does that shoot compared to the bullet variability test and the control test? So we can see, like, okay, we know the control shot, whatever. How does the bullet variability stack up? How does the charge variability stack up? And then for our testing conditions, and all of this was shot at 640 yards. Oh, we're getting into that here. So the temperature for the day, it was December 6th, I think. It was 28 degrees, was about the average temperature while I was there. I was there most of the day. And then the wind was averaging about 7 miles an hour coming from 4 o'clock. Pressure that day was 29.12 inches of mercury. I don't use density altitude. We won't go into that. Distance was 640 yards for all loads. Target size 22-inch tall by 30-inch wide rectangle, which for me at 640 yards, that might as well be a barn door. Why 640 yards? Well, that's far enough if you're going to try to test a load and see, test its viability for long range. 640 is enough to give you good information on, to be able to pick winners and losers. but also the landowner where I shoot, that just happens to be the distance where it's in that middle range, like 500 to 700 yards, somewhere in there, that he has there's like a pond and a slough and a cluster of like sumac. He does crop and cattle farming, and it's basically a spot where he allows me to set a target and leave it there year round. So it never has to move, never has to come down due to him putting crops in or harvesting or whatever. It can just stay there year round. So it works out. So that's why 640, why it's such a weird number. I think that's it for the testing conditions and what I tested. So now I think we'll take you out to the farm, show you all the testing footage, and then we'll come back and review the results. All right, we'll start out with our highest charge weight. We'll see how that goes. Shoot 10 shots in a row at a consistent cadence, and we're not really worried about left and right because the wind is switchy. We're just worried about what kind of vertical it holds, and that's what we're testing today for all the different loads. So far, so good. Starting to drift downwind a little bit, or upwind rather. I'm not too worried about it. And we are testing, this is a calibration, we're trying to see how flat the ammo will hold, you know, how good a water line the ammo will hold. We're not really concerned about the left or right, not really concerned about my speed. I'm just trying to control natural point of aim and good rear support, so that way I'm taken out of the equation as much as possible. And all we're testing is the ability of the ammo to hold vertical. I'm going to add a little bit of wind because I'm starting to drift off the plate. Should bring me closer to center. Take that back off. That one did drop a little bit lower. Kind of obscured my aim point. Right on the bullseye. That's okay. make it work. Right in there with the others. Wow. That was really good. That did almost exactly what I expected it to do, other than dropping that one out the bottom when I added wind. You know, on average, I think the one that hit the bullseye and then the one that dropped out the bottom on the left are the only ones that are like out of line with what the rest of them did. So the best 8 shots are all within like 1 to 2 inches of vertical, which is about as good as you can hope for given the brass I'm using, the bullets I'm using, powder I'm using, the conditions, it's cold out, you know, whatever. That's really good. So that is exactly what I expected to see with this load. Now we'll go down and repaint and shoot the next one. A little concerned about the elevation, but I think I'll let it go. Not bad. Not as consistent as the high charge weight, but pretty darn good. Those first 5 or 6 or whatever the number was, 4, 5, 6, unbelievable. did tell me no wind, which I forgot to take off from the last group, so that was my mistake. So this is where we should have been on the first shot. That's where we should have been on the first shot. Scared my point of aim, but it's alright. So my intuition to take half a minute off was right, and my wind call was right, but I forgot to dial my wind. Same spot. Same elevation. Pretty good so far. And one a little higher. It was a lot faster too. Right up my point of aim, right on the bullseye again. Ooh, threw one out the top. That was fast as well. That might have been me. Felt a little squirrely on the bag here. And another really consistent group. We're going from shortest to longest. Meaning the BC should get higher as we go. The bullets are longer, theoretically. Gotta quit hitting my damn aim point. So far, not seeming to matter.
ones now, so that shot went a little higher. Still right in there with the main cluster though. That one's the highest so far and the second longest. There we go. Already starting out high, that's not a great sign. So that was a higher charge weight and actually hit lower. Now here's a lower charge weight. And actually hit higher. Higher charge weight. That hit higher. I think we're on the lower charge weight now. Hopefully I stay on the target. That was one of the lowest charge weights and it's up on the top. I think that one down in the main cluster that we originally started with. Here's our second to lowest charge. Can't tell where they're going with the naked eye. I'm gonna have to review the footage. They're all kind of going together. But this is by far the tallest group of the day. That's the highest yet, and was our second to the highest charge weight. That was our lowest charge weight, and it was right in the middle. And our highest charge weight of the day, or for this group, not of the day, but for this group. Near the top. Alright, well, that was not a hard fast. If it's higher, faster, it goes higher, and if it's slower, it goes lower. That you see, that did not happen. It trended that way, sort of, where the lowest ones were like the middle charge weights, and then as we went lower and higher than the middle charge weights, everything kind of kept drifting higher and higher and higher. And I'll write down and see what the velocity was for each one. I'll be interested to see that trend you know, because we're getting more heat in the gun, all the shots are starting to get warmer, or what. And then I'll review the footage and try to plot where each shot was and see what sense we can make of that. But that's all I brought with the test today. So in my mind, I have a clear winner on which load I want to bring back and shoot steel targets with. But I'll analyze the data before I announce that. And then we just got to come back and I'll just go run through the targets and shoot steel and see how small the groups we can shoot and how consistent our final load is that we came up with. And that'll put a bow on this series, and we'll see what we can learn from that. So I'm gonna get packed up, go paint everything so it's ready for me next week, and head home.
All right, so as you can see, it really doesn't matter what we feed this thing, it just shoots incredible. Before anyone else asks, this rifle is gone. It was sold a long time ago. We had a guy ask in the comments on like the third video if we'd be interested in selling it. And despite how good it shoots, Dale was willing to part with it. So we sold it to a fella, I think he's in Indiana. And he's been testing a bunch with it and using my methodology, applying, you know, the things I taught in this series to his testing. And the gun is shooting unbelievable. So I'll be sharing his results with you guys from that rifle and what he's put through it and following my same process and all that. So before anybody asks about buying one, if you guys want us to replicate that gun, we'd be happy to build you one. That's not a problem, but that individual one is gone. So, and it's shooting unbelievable. So one thing I should say before we get into the individual testing metrics here, when I talked about low quality brass, and I talked about when and where that was going to rear its ugly head. So the two biggest places I've noticed over my lifetime of shooting where that will show up is in high average extreme spread, like we've been talking about, and also random flyers, random unexplainable flyers. And I can't tell you if it's due to an inconsistency in the metallurgy, like the actual brass alloy that's used for the case, if it is inconsistency in their heat treating process, or capacity, or what. I can't tell you why it occurs. I don't know. And there isn't really a good time to say it, so I'm going to say it now, I guess. And I'll probably beat on it a little more as we go through here. The guys that shoot at the very top level, they don't know why it occurs either. Which is why they use the very best brass they possibly can, and why they do 10 other steps that I don't do. It's all in an effort to get rid of those flyers. That's why they neck turn and sort and anneal every time and use expander mandrels and whatever, and use computer run like amp presses that read your seating pressure and throw gobs of money at this. They don't even know which one of those 10 steps that they do that I don't. They can't tell you which one gets rid of those flyers. They have no idea. So they just do them all in an effort to try to not have flyers. But as you can see clearly, you can still get most of the way there. Just through the methodology that I taught you guys, you can get most of the way to shooting the same amount of vertical they shoot with their 22-pound, God knows how many $1,000 competition rifles and a giant heavy-ass Seb front rest and a this and a that and a perfect everything and a whatever and all the extra steps they do and whatever. You can still shoot similar vertical to what they do, even with cheap brass. But you have to be willing to accept that you're going to get a flyer here and there. That's just, there's nothing you can do about it. Even if you did all the processes they do to that cheap brass, I think you're still going to get it. And in my experience, you can get rid of most of it or minimize most of it just by using good brass. Whether it's Peterson, Lapua, Alpha, ADG, maybe Norma, those are probably the top 5. If you use that brass, you're going to minimize those flyers without adding annealing or neck turning or any of those other steps. But with the cheap brass, that's just something you have to be willing to accept. You don't know when they're going to happen. They just happen. And you have to not read too much into it and just stick with what you're doing. And the shots will start to go back to where they should. But you're going to get that random flyer now and then. So you have to expect that. And that was kind of the point of this, is that I wanted to show you how much you can still do with cheap brass. You can still apply the same testing criteria and still do things the same way that I do and still do, still get most of the way there and get really good results. But you're still going to get those random shots that spit out, and there's nothing you can really do about it if you're using cheap brass. So, all right, let's go into the results here. I think I have this in order of how I shot them. So we got our higher charge weight, 43 grains IMR 4895, 175 grain Sierra Match King. I'll spare you the suspense. This was the winner for the day, by far, despite the fact that it spit one out the top and dropped one out the bottom. That's what I'm talking about. What I just got done talking about is this top impact might have just been part of the group. I doubt it. This one out the bottom, certainly not. That's a function of the brass. And I think really both of those two are a function of the brass, because the remaining 8 shots held sub 1 inch of vertical. And this is something that is going to really stir the pot, but too bad. We're going to talk about it anyway. So average velocity, 2743 for that day. Extreme spread was 23, which based on that extreme spread, if you look at the fastest shot and the slowest shot, that by itself should account for 2.3 inches of vertical. Not even counting the natural dispersion, which we've talked about, that there's nothing you can do about. That means that if all the bullets were headed for the exact same hole, you should get 2.3 inches of vertical just from the ES alone, which we did not. So our total vertical was 5 3/4, including these 2 outliers. And if you eliminate this one that went out the bottom, I think our lowest shot was right here. We're down to like 3 1/4. And I think, I'll look at the data here, but I think this highest shot was the fastest, and the lowest shot was second slowest, which is logical, right? Slowest shot should be the lowest, fastest shot should be the highest. However, all these bullets were the same length, so they should all have the same ballistic coefficient. So that we've eliminated as best we can. The reason I don't think that has anything to do with why these are where they are and why I think it's brass related is because in this band of 8 shots, this top shot was 2751. Well, the third shot was 2750, 1 foot a second slower, and it's in this cluster of 8. So just so we'll go through these. So the bottom shot was 2729 and the top one was 2751. Well, the remaining shots, so we got 29 and 51. The remaining shots in the middle were 49, 43, 50, 44, 48, 42, 44, and 28. So the slowest shot is in this band of 8. The second fastest shot is in this band of 8. So 1 foot a second slower than this shot is in here, and 1 foot a second slower than this shot is in here, and everywhere in between. So these hitting where they are has nothing to do with velocity. It's 100%. It's the brass, or maybe one of the bullets there was something wrong with it that I couldn't see or measure. Maybe there wasn't a weight issue. I don't know. I doubt it. All right, so the way I try to rank these, we look at shot distribution vertically from center. That's how I try to pick winners and losers, is I say, okay, based on the average impact location vertically of the group, where was the average center? And then from that average center, how did the shots disperse? Because like I mentioned, at long range, we're trying to shoot as flat as we possibly can so that all we have to worry about is the wind. That's the goal, right? Well, we see here sub 0.2 minute of angle vertically, so sub 5th MOA, 8 of the shots are in there. And they're actually in 0.1, they were 0.149 MOA, sub 1 inch for 8 of the shots. So the ES of those shots was 22. So the ES of 22 should be 2.3 inches tall vertically, plus the dispersion. However, they were sub 1 inch. Explain that to me. I'll wait. This is why I don't get super wrapped up in ES. Logically, the velocity should dictate the height. I'm telling you guys, that's not how it works. And all the competition shooters will tell you that too. I had a guy that I was talking to in the comments where, I don't want to say getting into it, but he made a comment about something, and I talk a lot about Air Cortina. Well, some of you may or may not know, he shot a 5-shot group at, it was either 1,000 or 1,050 yards, wherever he tests on that farm that he doesn't own, that he shoots at. He shot a 5-shot group one time. That was 1 3/8 inches. Okay? Preposterous, right? Just to even shoot that group is stupid. And it was like 4 of the shots were 3/8 of an inch. And then the 5th shot was 1 inch away, right? That's like the dumbest thing I've ever heard. That group, his ES was 29. So that group should have been this tall. Yet it wasn't. It was less than 1 inch tall. So, and he'll be the first one to tell you too, the ES does not dictate the group height. I know that's logical. I know you want it to be that way. That's not how it works. And you're going to see that as we go through here. So we had 8 shots that were sub 1 inch. So to me, right away, after that first one, I'm like, okay, this is the winner, because none of these other ones are going to shoot that well. And I was right. And then one of the shots was 0.2 to 0.4 MOA away from the average center. It was 0.373 MOA high. That's this shot. And then one shot was 0.485 MOA low from the center. So clearly, anybody that is paying attention can see that if we can have an extreme spread of 22 and hold sub-inch, these shots that spit out from it, they're flyers for whatever reason. That's not part of the group. That's the brass, the bullet, something. On to the next one. So that's clearly our winner. If you want to have a consistent rifle at long range and you are using good brass, this is what you should be looking for. Something that shoots crazy flat and defies the extreme spread. Second one, our middle charge that I thought would shoot okay, but it shot pretty decent at 100. Again, across our 2 charge weights and across our seating depths, it was shooting really flat and wasn't moving around much for average point of impact location. That's about as much information as you can glean from 100 yards. And once you go that far, you need to stretch it out and see what you really have. And I would say here it's kind of double grouping a little bit, and the shots sort of did track vertically with velocity. We'll go into this here. So our average velocity 2693, extreme spread of 47. Yuck. So our last one was an extreme spread of 23. And what that tells me is that this is a super happy load, and the only reason the ES is 23 and not single digits is because of the brass. Where this load, the ES was probably going to be in the 20s, maybe, but due to the low quality brass, 47, despite the fact that I'm weighing the powder to the kernel. So based on that extreme spread, again, all the shots are headed for the same hole. Extreme spread alone, the group should be 4.9 inches tall, plus the dispersion. Yet again, it wasn't. Total vertical 4¼ inches. Explain that to me. Shots tracked with velocity. What does that mean? Well, if we look at this, I basically put the velocity right over the bullet impact, so you can see basically height-wise where each shot landed. Because, you know, the horizontal, some of that's the dispersion, but some of it's wind too. So we're just trying to look at, like, how does this thing track vertically according to velocity. But you can see it's not as cut and dried as the slowest velocity is the lowest. We see 2651. I think that was the slowest. It's not the lowest shot. 2656 is the lowest shot, and 2663. These three shots have almost the exact same elevation vertically, despite 12 feet per second of velocity variation. And then you see 2666, only 3 feet a second faster, is a little bit higher here. And then the next highest one, 2675. And then 2695, which was the second fastest, but it's not the highest. And this is what you guys are going to see. These are not odd results. If you look online and you dig enough and you actually test this stuff yourself, you're going to see this. The fastest shots aren't always the highest, and the slowest shots aren't always the lowest. There's another phenomenon going on in there that I might talk about at some point in the series here that borders on witchcraft or magic, whatever you want to say, but we won't talk about it now. Next highest one, 2679. Again, just slightly higher than the 2695, despite being 16 feet a second slower. 2671, this is one of the highest shots, despite being well below the average velocity. 2693, that doesn't sound right. No, that's a typo. So the average is 2673. That's a typo. I flubbed that up. The 2671, basically right at the average, and it's the second to third highest shot. And 2698, that was the fastest shot, and it's up near the top. And then 2675, again, 2 feet per second above the average, and that's the highest shot. So this isn't as simple as we all want it to be. You have to go out and shoot this stuff and see what you get. And again, all these bullets were sorted to the identical length, so there shouldn't be, we should have minimized ballistic coefficient variation as much as possible. This is just the dispersion. That's why you got to test farther than 100 yards to see what you really have. But this one was a lot more evenly distributed across that vertical. So shot distribution vertically from center, only 2 shots were sub 0.2 MOA from the average center. 4 shots were 0.2 to 0.4 MOA within the average center, vertically, going up and down. 3 of the shots were 0.4 to 0.6 from the average center, and 1 shot was 0.6 to 0.8 MOA away from the average center. So, just okay. That total group vertical at 640 yards, 1 MOA is 6.7 inches. So that group is still only 0.634 MOA tall. Not bad at all. The whole group is 4¼ tall, and it's probably, I don't know, 6 or 7 inches wide. I mean, it's like this big. Very small for 640 yards in the butt cold and the wind and whatever with a dumpy 308 load. This thing just shoots unbelievable. Next one. 40.8 grains, IMR 4895. This was our kind of control where there was no load development whatsoever. I found this to be a little bit interesting as well. Average velocity 2573, that is correct. Extreme spread of 43, it's the same deal. We're lower in the pressure range. questionable on whether or not we're getting 100% burn in a 26-inch barrel. According to Gordon's reloading tool, we're not. So that could be playing a role. Same deal. Should be 5 inches of vertical plus the dispersion. Vertical was only 5 3/4, including, as you see, including that flyer, which was, I don't know if I marked what shot that was. I don't think I did. But at any rate, the remaining shots, I think I got another picture here. Yeah. So we see this shot out here where, remember, I forgot to dial my wind. And then once I dialed it, everything piled up around the group center. So we see vertically, that's right in the middle of the rest of these. So if we go to this next slide, we know that the remaining 9 shots stayed within, what is that, 3 1/8? Yeah, 3 1/8 without the flyer. So without that flyer, our ES was 40, which means it would still be 5 inches or damn near of vertical plus dispersion. And again, despite that, it was only 3 1/8 tall. Again, more proof that you see the ES, you guys are reading way too much into it, most of you. It's not nearly as important as we all want it to be. Shot distribution. This one shot really consistent. Better than our middle charge weight, despite the fact that we did no load development whatsoever. Sub 0.2 MOA, we had 6 shots that were within basically like 11/16 up and down from the average center. And then if we go another 11/16 each way, that encompasses another 3 shots, and then we had that one flyer that blew way out the top. And still, even including this flyer, 5.75 divided by 6.7 is 0.858 MOA. Still sub MOA. Still really, really good. Now we're going to get into our average control with the bullet variability. So what I see with this is that although the remainder of the metrics are very similar to this, like I said, the only difference is we had that 10,000ths variance in bullet length. All I can see that's really different here, the extreme spread is very similar, 43, 46. We can say that's basically the same. This group didn't get a flyer. So whatever was going on with that brass, we didn't have any oddballs in there where I would say this is a reliable group with no flyers. And what we see here is that because we captured all 10 shots with no flyers, we see that because we had that, in my opinion, I think because we had that variation in bullet length and therefore BC, we see that the shots are more evenly distributed across that 4.25 inches of vertical. So we'll start at the top here. Same deal, 2577, average velocity, same charge weight back here, 4 feet per second different. That's pretty typical. ES of 46, again, should be 5 inches of vertical plus the dispersion, the random dispersion, and it was only 4 1/4 tall. Again, beat that to death. Sub 0.2 MOA from average center, we only had 4 shots that we caught going basically 11/16 either direction. And then if we go another 11/16 those directions, we only caught 1 more shot. And then had to go 11/16 again to catch the remaining 5 shots. So we see that having that variance in ballistic coefficient, it just more evenly distributed the shots across the vertical that it had. So this total vertical was 4 1/4 with no flyers. This one was 3 1/4, 3 1/8. This last one, that where all the bullets were the same. So having that variance, in my opinion, grew the vertical by, what is that? 7/8 and a quarter. What's that, like 1.125 inches? So it grew the vertical by 1.125 inches and more evenly distributed the shots across that vertical. And again, that was only 10 thousandths variance. So those of you guys that are shooting lead core hollow point bullets that have really high BCs that are a VLD or a hybrid design, if you're not sorting them, this is what you can expect. Where your shots are, whatever your vertical is, your shots are going to be more evenly distributed across that vertical. And on average, your vertical is going to be higher than if you were sorting. So I know this is pretty fringe stuff that not everybody's going to do, but for those of you that are trying to get the very most out of your system at long range, if you're shooting hollow points, you need to be sorting them. If you're shooting monos or tipped bullets, there isn't really a lot of value in sorting those. You can still sort them even if they're tipped, because if they are different in length, they're going to have different BCs, but you're going to see that the length variation is way less than a hollow point bullet. Same with a mono. Like this, a monolithic solid like this that doesn't have a tip. These are CNC machined, so they're all going to be the same length, which is why ELR shooters primarily use these. The CNC Swiss lathe cut monolithics, because they're identical from bullet to bullet, so the BCs are nearly identical from bullet to bullet, which matters for ELR. And that's where extreme spread starts to matter, is ELR and also bullet to bullet consistency. They're not looking for the highest BC necessarily, despite the fact that they're trying to shoot 2 miles. They're looking for a high BC that's consistent from bullet to bullet. They don't want the highest BC. They want the most consistent one. So that it's very important, as you guys can see. I know this doesn't show it as well as I maybe would have wished that it would, because this gun shoots so well. But I'd invite you to go test it on your own, sort your bullets, and find the biggest variation in length throughout the box, 40, 50, 60 thousandths. Grab some bullets that are evenly distributed across that, and then have the rest of your stuff that you sorted. Do your load development, and then when you have your polished load, load up 10 or 15 shots that are all in identical length, and then load up the 10 to 15 shots that have that giant spread in length, and go shoot them at long range, and you're going to see this. You're going to see that the ones that are unsorted, or that you intentionally picked the biggest separation, is going to shoot way taller than the other one. This is not hard to replicate. And then the last thing we tested was charge weight variability. And this one is probably going to blow the most hair back and make the most eyes cross of anything we did. I could probably do a video just on this test. Where do we start? Again, our charge weight variation that we tested was 40.64 grains to 41 grains. Average velocity was 2606. The extreme spread was only 43, despite the fact that we had 10 different charge weights. Where this last one that we just tested, were all the same charge weight, and the ES was higher. I could spend the rest of my life trying to figure that out and not figure it out. Again, based on that, should be 5 inches of vertical plus dispersion, and we only had 5.5 inches, despite having almost 0.4 of a grain powder slop. Same deal. Shots are very evenly distributed across. So we see this is higher. This group is taller, having 0.4 grain charge variability, created a taller group, spread across the same, with 40.8 grains as the average. It was 1.25 inches taller. Or no, yeah, 1.25 inches taller. And again, evenly distributed. However, if we look at the actual group, I put the charge weights, coinciding velocities, and impact locations of these. So the way I tested it, I explained it in the video, but I didn't want to overly bias this one way or the other. So I was trying to think of how to do this, because I know from experience that had I started with the fastest charge weight and worked my way toward, the highest charge weight, 41 grains, and worked my way toward the lower charge weight, as I build heat in the barrel, those lower charge weights are going to get some artificial help from heat. So I thought, well, if I wanted this charge disparity to shoot really flat, that's how I would shoot it, is I would start with the fastest charge weight and go to the slowest. And that would make as the heat gets into the barrel, the slower charge weights are going to go faster and make a shorter group. And if I wanted to bias it the other way and make the group super tall, I would do it the other way. I'd start with the lowest charge weight and work my way to the highest charge weight. So as I get toward the higher charge weights, there's more heat in the gun. That's artificially going to make them blow out the top and create a super tall group. So I thought, what I'll do is I'll start in the middle. I'll start with the 5th charge weight, shoot that first, and then shoot the 6th, and then the 3rd, and then the 7th, and then kind of go back and forth and work my way out to the extremes. And what ended up happening was I feel like the faster or the higher charge weights didn't shoot necessarily faster than they otherwise would have, but the slower charge weights, so instead of having velocity like this that tracked evenly with charge weight, these lower charge weights kind of went like this, where the middle charge weights when the gun was cold were actually slower on average than the lower charge weights. And we see here the average point of impact location. There's no rhyme or reason to this. You guys can analyze this to your heart's content. We're not going to be responsible for any nosebleeds or brain aneurysms you suffer trying to figure out what the hell's going on here. I stared at this for almost an hour, and I can't make sense of it. I went over the numbers, and I'm like, okay, well, maybe like looking at the order they were fired in and watching the video, and there's no rhyme or reason to this. I see that it looks like the faster shots on average are higher, so that kind of tracked logically. The slower shots on average are lower, but look at the charge weights that produce them. So our lowest charge weight was 40.64. That's near the bottom. Then the next one would be 40.68. That's right near it. Next one would be 40.72. That's way the snot up here. 40.76 back down to the middle, so despite having more powder, it's lower. Then 40.8. That's even lower. So as we're adding powder, we're getting lower. Then 40.84. So that's like almost the middle charge weight, and it's the lowest one. And slower than charge weights that had less powder in them. And then 40.88 is way the snot up here. 40.92 way back down here in the middle. So basically, in summary, I don't know what the right way to test this is. I thought I tested it the way I thought would not have skewed data, but clearly that there's no logic to this at all. So I think maybe the best way to do it would be to do it twice and do, like I said, go from lowest charge weight to highest charge weight, record the data, take pictures, and then paint the target, and then do the inverse. Start with the highest charge weight and shoot to the lowest and see what the difference is, and maybe try to draw some conclusions from that compared to a control. I don't know. Maybe you guys have some ideas, or maybe some of you have tested something similar to this, but I couldn't make any sense to this. I see that the group on average is taller than the one with bullet variability and the control main cluster. And it's evenly distributed across that vertical, but other than that, there's no rhyme or reason for this. I can't make sense of it. All right, so that's it. Now we'll go into my conclusions, if I can draw any. So for me, number one, 43.0 grains is clearly the best load for shooting long range based on 8 shots holding sub 1 inch of vertical, despite an ES of 22, which should have been 2.3 inches tall by itself, and not even including the natural dispersion or variation in BC from bullet to bullet. So that's our winner. So now we're going to load up, I think I loaded up like 50 rounds or something like that, the remaining bullets that I had. And we're going to go out and shoot steel for the day like we did with the barrel break-in. And then we can kind of look and go, okay, how did it perform with full load development using my process? How did it perform group size, vertically, whatever, even though they were shot months apart compared to the barrel break-in load, which had no load development whatsoever. And I shot the same distances at the same targets and whatever. Number 2, there is not a one-to-one relationship between ES and group height. You can take that to the frickin' bank. I said this before. At some point, I think it matters. At 640 yards for me, and at 1,000 yards for me, and at 1,000 yards for many national level competitors and world champions and whatever else, there is not a one-to-one relationship between ES and group height. The groups will shoot shorter than the ES dictates, not even counting group dispersion, most of the time. I don't know why. I can't explain it to you. I have a theory. It's a common theory in the industry, and we'll talk about it later, but you can't explain it logically just by math. The group height was shorter than it should have been based on ES for every group when obvious flyers are eliminated. Number 3, well-groomed loads do not always outperform randomly selected loads, as we saw with our mid-range load and our control. The control was just, again, it was one of the bottom 2 charge weights. Only there was a way. I'm not going to be able to pull it up for you guys on the camera here without, or on the screen without a bunch of screwing around. 40.8 grains was the lowest charge weight. That was tall. It was 0.815 inches tall and had an ES of 10. But then when we increased the sample size and shot it in much colder weather, the ES went up into the low 40s. And my opinion, didn't really shoot as tall as I would have predicted based on how it shot at 100 yards. And again, outshot our well-groomed mid-range load in a sample size of 10 shots, despite no load development whatsoever. So this is why I don't want you guys to, I guess this third point is to hopefully convince you guys to not spend every second of your life at 100 yards. Yes, we did very thorough testing in this series at 100 yards, but in my experience, that's the best way to try to find, like what this 43.0 grains did, where it just defies logic with how short it can shoot. That's the best way to find it. But not every group you find by my criteria is going to always perform. That's why you have to, it's just a contender. You have to take it out and shoot it against your other contenders and see when the rubber meets the road, which one is actually better. Because 100-yard metrics won't always tell you which one's better. We talked about that a lot in the 7mm Showdown series as well. So I hope this third point here and these test results show you that just if you think something has potential, go stretch it out and see what you have. It doesn't, 100-yard metrics are just, those are just trends. It's just a very small sample of what is this thing capable of. You have to get it out in the air for some time to see what it does at distance. Number 4, bullet length variation increases group vertical versus control and more evenly distributes the shots across that vertical. I think that's fairly obvious and it's logical. Number 5, large charge weight variability, almost 0.4 grains, increases group vertical versus control and versus bullet length variation. During this test, the shots with lower charge weights had higher velocities and trended higher on target as barrel heat increased. The slowest shots were the middle charge weights. That this test has been, had this test been shot from lowest to highest charge, I speculate that the group height may have doubled. This really intrigued me, and I intend to test this theory in future with other rifles. I'm definitely going to play with that some more because that one surprised me the most, I guess. And I'm really curious what would happen, again, if I, as I said, if we shot them one way or the other, shot lowest to highest and then highest to lowest, and a control, and that didn't have any variation in charge weight, and see what we get. And number 6, low quality brass causes unexplainable flyers and high average extreme spread. That's what I've noticed over my lifetime of shooting. This is not a unique situation. with the 308 and IMR 4895. I think that combination of cartridge, powder, and bullet are capable of incredibly low extreme spreads, provided you have high quality brass. And not all powders are created equal. Like I would bet if you used Vitivori N140, on average, your extreme spread is going to be lower than IMR 4895, even with the same brass. I think, certain powders are capable of greater performance than others, but that's provided they both have a good foundation, a good, consistent piece of brass to work with. So I wasn't sure when I was going to let that cat out of the bag, but you guys were going to see it, and we needed to talk about it. And you're going to see it when I do the final steel shoot on all the targets at different distances at the farm and show the final performance of this load that we found. You're going to see it where it's just piling them all in the same place, and it'll just randomly spit one off in no man's land. Well, that's the brass. And like I said earlier in this video, the competition guys will go to great lengths to try to get rid of those, or try to minimize them and keep them with the rest of the group. And they can't tell you which step does it, which is why they do all those extra steps that I don't do. Because they just, it could be any one of these, so I'm just going to do them all, and that way I've eliminated all of those variables. And you can't say that they're wrong and that it doesn't work, because those guys can hold incredible vertical at distance. But you have to decide for yourself if you want to commit that amount of time and resources to try to get rid of one random shot here and there. For most of us, it's just not worth it. But you have to decide if it's worth it for you. So I think that's it. That testing was a lot of fun. I'm curious to see what you guys have to say in the comments, what your feedback's going to be on this. It was really interesting for me to do and a lot of fun. And I think, again, in my opinion, I think that faster 43.0 grain load is clearly the standout. So that's what I loaded up the remaining bullets that I had with, and took it out at the farm and banged away at steel. So I think that's what we're going to do next, is we'll show that video of the final steel shoot. And then after that, I think I'll do a conclusion video and put a bow on this series, and then we'll move on to something else. I don't know if there's anything we're going to add to this series later on. Maybe. Dale and I have talked about it a little bit. We're kind of undecided on if we want to do anything else for this down the road, but there's a lot of other projects we have going on that I need to get to and spend time on. So probably be these remaining 3 videos, this video, the final steel shoot, and then a conclusion video. And then we'll be on to something else. So thank you guys. I really appreciate you. Like, subscribe, share with your buddies, all that. We'll see you next time.